Good morning, all. I'm Dr. Sherin. Today, I'll be taking a small class about methane, how the bonding happens in methane. This is a simple view of bonding in methane, dots and crosses diagram of CH4. And we can see that the modern electronic structure, there are two unpaired electrons in carbon, that is 1s2, 2s2, 2p2. Two unpaired electrons are there in the p orbital. Then why it is forming CH4 instead of CH2? Here comes the importance of bond formation. When bonds are formed, energy is released and the system becomes more stable. If carbon forms 4 bonds rather than 2, twice as much energy is released and so the resulting molecule becomes even more stable. And there is only a small gap between 2s and 2p orbital, so it pays the carbon to provide a small amount of energy to promote an electron from the 2s orbital to the empty 2p orbital to give 4 unpaired electrons. The extra energy released when the bonds formed more than compensates for the initial output. That is, the initial input by the carbon is compensated by the extra energy released during the 4 bond formation. That is, 4 bonds are formed instead of 2 bonds. Here you can see the promotion of electrons from s orbital to the p orbitals for bond formation. Now we have 4 unpaired electrons. And you know that in methane, all CH bonds are identical, but our electrons are in two different kinds of orbitals. We are not going to get identical orbitals unless we are starting with the same 4 identical orbitals. Here comes the importance of hybridization. Chemist Linus Pauling first developed the hybridization theory in 1931 to explain the structure of simple molecules such as methane. Here, in this process, electrons rearrange themselves in this process. Here, you know that the one electron is in s orbital and 3 electrons are in p orbitals. This rearranges or reorganizes the electrons into 4 identical hybrid orbitals, that is called sp3 hybrid orbitals. These sp3 hybrid orbitals, you can see here, one s orbital is spherical in shape and the p orbitals are dumbbell in shape, and these 4 orbitals reorganizes themselves to form the sp3 hybrid orbitals, and the orbitals are placed in such a way that they are as far apart as possible, forming a tetrahedral arrangement with a bond angle of 109 degree 28 minutes. Then these atomic orbitals merge to form new molecular orbitals that contains the electron pair which creates a bond, which this then overlap with the hydrogen s orbital of hydrogen to give the molecule that is methane, CH4. The 4 sp3 hybrid orbitals rearrange themselves as far apart in phase as possible, pointing towards the corners of a tetrahedron. This shape doesn't change when the hydrogen atoms form the molecular orbital. Thus, CH4 is having a tetrahedral shape with 1 carbon atom and 4 hydrogen atom bonded to it. Thank you. Now I would like to present a new small video on how hybridization happens in the case of methane. You can watch this video.
sp3 or tetrahedral hybridization. Definition: the process of intermixing of 1s and 3p orbitals to give 4 identical hybrid orbitals is known as sp3 or tetrahedral hybridization. Characteristics of sp3 hybridization. In this hybridization, 4 hybrid orbitals are formed. These hybrid orbitals take the direction of p orbitals. Each sp3 hybrid orbital possesses 25% s character and 75% p character. The hybrid orbitals are oriented along the 4 corners of regular tetrahedron at an angle of 190 degree 28 minutes. Hence, this hybridization is called tetrahedral hybridization. sp3 hybrid orbitals are bigger than sp2 and sp hybrid orbitals. Therefore, the shape of sp3 hybridization atom is tetrahedral with an angle 109 degree 28 minutes. Examples: CH4, methane, C2H6, ethane, NH3, ammonia, H2O, water. Structure of methane, CH4 or formation of methane. Consider methane, CH4. The central atom is carbon in this molecule. The atomic number of carbon is 6 and general electronic configuration is 1s2, 2s2, 2p2, which is ground state electronic configuration of carbon. The excited state electronic configuration of carbon is 2s1, 2p3. One 2s electron is promoted to 2p2 orbital, then electronic configuration of carbon 1s2, 2s1, 2px1, 2py1, 2pz1. The 2s and 2px, 2py, 2pz orbitals of carbon undergoes sp3 hybridization and form 4 identical hybrid orbitals. These 4 sp3 hybrid orbitals have 1 electron each. In methane molecule, the 4 sp3 hybrid orbitals of each carbon atom overlaps axially and separately with 1s orbital of 4 hydrogen atoms and form 4 sigma sp3 s bonds. The 4 sp3 hybrid orbitals are directed towards 4 corners of regular tetrahedral with bond angle 109 degree 28 minutes. Therefore, the shape of methane molecule is tetrahedral.
Thank you for watching the video. I think now you have understand how hybridization happens in the case of methane.